Alright, it is now time to do the machining on setup 2 for the other side, or front side of the clock face. First thing I'm going to do is a 3D adaptive clearing. I'm going to select this 3/4 inch tool. Under geometry, I think I can just leave this. For retract height, I'm going to make that a full inch. I'm going to use stock top and model bottom, but I'm going to go minus 0.05 on the model bottom. For stock to leave axial, 20,000ths of an inch should be enough. On maximum roughing step, I'm going to change that to just 1/10 of an inch. And all of this can be left as it is. I'll click OK. And we have a toolpath. So this will remove all of this outer material and leave a rough edge right on the edge of this. Alright, so we have this roughed out. The next step is to make a finish pass around here. So I'm going to go to 3D, Adaptive Clearing. I want the 3/8 inch end mill. Click OK. For rest machining, that basically means follow the previous step. I'm going to go from previous operations. I'm going to make the retract height 1 inch again. And stock to leave, I'm going to click off. I can just click OK. And it provides one finish pass all the way around there. Alright, we need to put the chamfers on now. Unfortunately, we can't do this chamfer because there's a bolt going through that hole, but we can do the outside one. I'm going to go 2D chamfer. Use this 1/4 inch mill drill that's fudged in there as a chamfer tool. And I have noticed that the chamfer tool can be a bit finicky, and or I have a lot to learn about it. Originally I had tried selecting this lower line on the chamfer. That didn't work. I tried this one. That didn't work well. So finally I selected the top one. Got that to work. Something that I should point out, you see this arrow? If you click on it, it flips sides. So here, the tool would be traveling inside that line around the part. That's not what you want. I'm going to flip it back out to the outside. Here I'm going to set the retract height at 1 inch, the top at stock top, and the bottom at the selected contour is great. Chamfer width, I'm going to set to 0, and chamfer tip offset, I'm going to set to 0.03 or 30,000ths. And click OK. And if I zoom in here, you can see this is the path that the chamfer tool will follow, and that will work. All right, now we need to drill and tap these holes. So the first thing I'm going to do is a drill operation. I'm going to select the center drill. And hole faces, I'm going to select this hole, and this hole. Now for heights, the retract height, I'm going to set to 1 inch. The top height is the top of the hole. The bottom height, I'm going to switch to hole top minus 0.06 inches. And I'm going to leave this at drilling rapid out. And click OK. There's our tool path for that. Now I'm going to go back to drilling and drill again. Need a different tool. This time I need the number 36 drill bit. That is 0.1065 inches in diameter. Click OK. I'm selecting the exact same holes. Heights, retract height at 1 inch again. Hole top at 0, hole bottom at 0 minus, let's see what 0.06 does. Does that bring the drill bit all the way out of the hole? Looks like it does. And then over here on cycle, I don't want drilling rapid out. I want deep drilling with full retract. And I'm going to click OK. Now we need to tap. You go to drilling, drill, going to select the tap, tool 71. Here under cycle, it automatically goes to tapping. I'm going to leave the dwell at 0. I need to select these holes again. This hole, and this hole. I'm going to put the retract height at 1 inch, hole top at 0. I'm going to do hole bottom minus 0.1. I want to be sure that the full threads on the tap all the way through. In fact, I should probably make that minus 0.15. Okay. Now the last thing we need to do is engrave the numbers on the clock. For that, I'm going to go to Engrave, and I'm going to select this chamfer mill and the geometry. Just go around and select all these sketches. I'm going to set the retract height to 1 inch, the top at selected contours, and I'm going to leave what it calculates there for the bottom height. And the rest of this I'm going to leave as it is and click OK. And there, it's developed that tool path. Now I'm going to flip this over and simulate the entire milling of the back of this. I'll right click on Setup 1, click Simulate. I've got the stock on there, it's transparent, and I'm going to play. Now if I zoom out, it speeds up. If I zoom in, it slows down. You can also adjust the speed here. Now it's chamfering the outside. Chamfering the inside. Chamfering that hole, and it's done. That looked pretty good. I'm going to flip the clock face over. Right click on Setup 2, click Simulate. I'm going to leave this stock on and leave it transparent. Go ahead and press play. And you can see in the simulation here very clearly where it's removing the stock. I'll zoom out to speed that up a bit. All right. Now we do the finish pass around the outside. Now it's chamfering around the outside. Now it's going to center drill each of those holes. Drilling each of those holes. That full retract allows chips to clear. Now it's tapping each hole. And now it's doing the engraving work. It's hard to see in this simulation, but the engraving work actually has a fairly neat effect. It's using a V-engrave. Let me see if I can zoom in here on the 4 to see this. No, I can't, but you'll see it on the actual part. And there we have it.